So when it comes to electric motors, one of the main losses of efficiency and how powerful you can make a single electric motor and how lightweight compared to its power and stuff has to do with heat problems. Is that when electricity moves through something, it gets hotter, and hotter things also are more resistive. So it's a kind of a feedback loop that eventually settles down. Now, if you can cool the motor more, you expend energy cooling, but it might run more efficient. And there might be less wear and tear. Also, heating might make stuff expand in the motor, and if it doesn't expand all right, it can cause problems and more wear and tear. Another thing I want to point out is carbon nanotubes are the most conductive thing, and the most thermoconductive and the strongest along a certain direction, along the length of them. What a carbon nanotube is a tube made of like hexagons, repeated hexagons, and each of the hexagon there's carbon in it, and you can have many layers, that tube, or you can have single layers, and there's other different types of carbon nanotubes. But copper is usually what we use because it's a lot cheaper and easier to process and make. This paper and other people are trying to talk about making metal composites with carbon nanotubes in it to kind of get the best of both worlds. And another advantage of metals, though, compared to carbon nanotubes, is they're not only strong or conductive in one direction, they're in every direction. So that can help balance out the problems if the tubes are not perfectly aligned. But I want to notice that in this paper that carbon nanotubes make copper about 14% more conductive. The way they do it in this paper, which might not be the best way in the long run, is that they first deposit copper, then they deposit using a spray method. Carbon nanotubes dissolve in a solvent, which then they evaporate off the solvent and they spray out more copper, but each of the micro layers mixes together very well. This could be useful maybe in 3D printing motors for more precise geometries, for example. But in the 3D lasers and melting for the copper could help mix it and evaporate out it, but using less solvent will make it more environmentally friendly, or if you figure out a different solvent. You could also try to compress it and compact it to make a more dense structure. More dense structures are usually more thermally conductive, and they can also less resistance, suppressing it with lasers and stuff. So lasers could be the way forward to making this even better. It will take more energy to make, but the material will be better, and it might save energy over the lifespan of using it as a motor. But this could allow for more compact motors, and if it's more thermally conductive, you don't have to put as many cooling channels, so you can make the motor more compact, also saving weight and cooling stuff. But not only that is a problem when it comes to designing electric motors, there is another problem, and that is itself that you can have it that mechanical stress, these magnets can sometimes want to attract each other and pull each other or tear each other apart. And carbon nanotubes are by far the strongest material. So this composite could be easily 50% to 1,000%. So 1,000%, so anywhere from 1.5 to 10 times stronger. In here they have a 20% strength increase, and they say a 14% resistivity increase. The thermal conductivity, though, is if you look at papers like copper being 386, and then you found carbon nanotubes up between 2,000 and 3,000. So a single carbon nanotubes can improve thermal conductivity by over 5 times to nearly 8 times, or a little over 8 times. So huge advantages there. Also, with the new process like C2, CNT, and carbon step process, carbon can actually be made out of CO2, making this even maybe more green, offsetting the problems with destroying the solvent, and also electricity can be used instead of sometimes refining stuff, which oftentimes refining uses actual coal to make CO carbon monoxide, which directly to reduce stuff. Instead, you just use electricity, which can be made from green ones. So there's a lot of advantages of maybe making this more green. In fact, right now we already do use a lot of graphite in some of the best high-end motors, but separate in the cooling jacket. Another potential way that this could be a wonderful new invention is that you could have extra copper carbon nanotubes windings around the whole thing. And these carbon nanotube windings can be turned off, and this uses like heat dissipation, but to be turned on for certain bouts of more power where heat does build up. And then you let it cool down more by incorporating both systems together. So you could have a booster pack that you can't use too long. You could also have it work in more extreme environments with higher temperatures or higher mechanical stress, have it last longer for more reliability issues, and a bunch of other things. Now this is all theoretical, but I also want to say when the best results were 10% with a little bit of carbon nanotubes, less than 10% in there, because that's what they use the solvent. So only a very little bit of carbon nanotubes were actually in the composite. But if you put more carbon nanotubes in composite, you could get even higher efficiencies, which they did not explore in any way, mind you. So, potential, and there's ways to even make carbon nanotubes better. Something that we haven't explored too much is boron. Adding boron to carbon nanotubes can make them both more thermally conductive and electrically conductive. Even though I did say carbon nanotubes are traditionally thought thermally the most conductive, electrically conductive, the most traditional material that's not superconductive is boron doped and at room temperature. Thermally conductive is traditionally thought to be carbon nanotubes in one direction, but there is some hints that boron might make it a little bit, just adding a little boron into it. This boron might make it also a little stronger in the composite, not in real, because in the composite it might make it have a better interface with the copper. Now, pure carbon nanotubes are stronger, but if you can make the motor have less heat stress and stuff, and other stresses because it's working more efficiently, then maybe loss of strength is okay. And also you don't always need the strongest material. Or if parts that have more stress, you can change up what material you use. So you could have mix and matches that way. And I just want to say that I really think the possibilities here are pretty endless, especially when you take into account doping. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave them in the comment section below. And lastly, I want to say is, I will be leaving the links to these articles and some information that is not easily Googleable in below, but this is something that a lot of people are working on. And if you want to go in depth, I do suggest a big Google search. Well, thank you very much again. Goodbye.